If you told me 5 years ago that today I'd be headhunted by Apple, Google, and Netflix to build AI for self-driving cars, I wouldn't have believed you. Because at the time, I was working on film sets, physically rigging lights, and fixing 3D models for a living. I had zero computer science degree and zero background in math. This isn't just a motivational video. Today, I'm going to share the specific roadmap, the exact books, courses, and boring skills that actually got me hired as an AI engineer. Let's get into it. When I started out, I almost had no skills at all. And back then it was a lot harder to learn because not everything was on the internet. In fact, internet was really, really slow and there weren't many web pages. So I had to go to the library or buy books, mainly to the library because I didn't have much money to actually buy books unless they were on sales for like $1 for an older version of a certain syntax or of a certain language to learn the syntax. And just that, I was just memorizing syntax because they didn't give you any actual code or any real project to work on. They just mentioned a whole bunch of things to memorize or a bunch of code that you had to memorize. It's kind of like if I was trying to learn the English language just by reading the dictionary, right? Just that alone. I never see the context, never had a conversation with anybody. So when I actually try to start the code, even learning how to get the code to compile or what software to use to compile it, that was overwhelming. That took a while to figure out. And even when I did get it to work, it had a lot of basic errors, such as indentations or forgetting to put a semicolon. It really broke the momentum because just the basic things would trip me up, and I wasn't even actually doing anything actual practical that actually move the needle to move me forward. But what drove me, so I kind of gave up at the beginning, but like what kind of drove me to return was the fact that, doing a manual job at the time, and I'm like, okay, there has to be a better way than continue doing this because you're never going to get out of this if you don't try to improve on it. But so I took a step back and I learned what I realized is that it's better to learn systems first before you start building intelligence. And what I mean by that is that get things to work, make sure they work together before you start going to another level. So I actually started beginning with web development when it was a lot more accessible, especially around the time that was really very popular. So learning APIs, data flow, how it goes from one place to another, and then the app structure so they could talk to each other. And that really helped. And also it's also accessible because everyone has a web browser that's universal, and I was able to build tiny scripts, tiny pieces of code just from documents and just see them work. It wasn't necessarily magic, but the code actually processed something and got an end result, and that was very motivating. So once I understood kind of like how to code and build an app from beginning to end, actually did something, that's when I started pivoting specifically to ML or machine learning and AI or artificial intelligence. So that is a more specific thing I was going after, like to solve it and how to actually use it. That took about a 3 to 4 month of obsession because there's just so much you had to learn out of it. And the other thing is, if you try to do the academic route, which I didn't go directly with, I started with a certain project that I wanted to solve, try to solve it with my current knowledge with coding, and then hit a brick wall. And then I had to start learning how to actually solve it using AI and ML. This is what I call just-in-time learning. So I go as far as I can until I can't because I don't know a certain skill. Then I go in and learn that skill to get past that wall or that blocker. And then as soon as I know enough to get by, I just continue going. And that helped me avoid the going down a rabbit hole and just going through endless tutorials of learning everything. Because especially if you go on YouTube, you see a video, then it says look on this video, and then you look at this video, it keeps linking, and it might not be relevant. So basically I learned math on demand. So when I was actually going to ML, doing machine learning and building neural networks, and back then, you didn't necessarily have, like PyTorch or TensorFlow. You actually had to code it out yourself. So I had to learn what a gradient descent was and what back propagation, the basics of it. So I learned just in time to learn what it is, be able to implement it and move on. At the time, papers were the primary source of textbooks because AI and ML was moving so fast that textbooks itself weren't keeping up. So every week there's a new paper, and I was able to read it and try to implement math in Python, and that was a lot of work. But you start getting used to it, you start seeing the same type of pattern. And yes, it was super messy, and that's actually how you learn. It's from all the mistakes, and not that it's perfect and polished because you're dealing with real projects with real world data and real world scenarios, and you have to have AI tools that actually make it work. And in my case, I was dealing with more like 3D work because I came from the VFX, Hollywood films, and like AAA video game world. And there were a lot of problems that you need to solve. So I knew what the end result was supposed to look like, what success was supposed to look like. And I knew the data sets we're working with and the conditions we're under. So we had to make all this stuff work under these conditions. And it was hard, especially since there's nothing really out there for it at the time. You had to kind of make it work. And I guarantee you don't feel like you know what you're doing until it actually works. And the more you do it, you start becoming more confident, because confidence comes from competence. So the more you do it, the more you'll be able to solve problems and get across the finish line, the more confident you'll feel because you've done it before, right? And pretty much the reality I found out of most AI jobs, even until today, 80% of it is really just data engineering. You're pretty much doing the same type of framework, but a lot of it is actually dealing with real, messy, raw project problems that they're not curated, they're not perfect. As if you were to go and learn it nowadays, they'll give you a perfect data set to work with. Everything lines up. In the real world, you have a lot of things missing. But there is a certain way you work with, and there's certain tool sets that will be great. And that's where like the data engineering part, becoming like a data scientist, knowing the basics of it, and learning pandas, NumPy, and basically the concept of how you clean data, that was extremely helpful for you. My first job in AI was actually building prediction models for the stock market. And one thing that helped me work on that is reading the book Trading in the Zone. And that's mainly for me to understand the psychology of stock trading for that. Not necessarily because I wanted to be a stock trader myself. It's just so I could actually have domain knowledge, because having domain knowledge of whatever you're doing is an advantage. One thing I was fortunate for because I worked in film, I knew film pipelines, and I was able to transfer that over into finance, because both of them dealing with large data. You want to have low latency, and you have feedback and how to process them and actually give a meaningful result at the end. This is not a science experiment. You actually have to have an ROI for the company to actually care. And knowing math, not surprisingly, is very useful for debugging, mainly because just like in computer graphics or film pipelines or video game pipelines, all this math is actually dealing with linear algebra. That's why GPUs, which was designed for graphic processing units, were designed originally to expedite video games, was very helpful for AI and ML, AI, artificial intelligence and machine learning, mainly because they use linear algebra. You don't necessarily have to be a PhD level to work with it, but understanding math will help things debug when they're not working pretty well. And later on, I did go back and fill in the math gaps, because the more you know, that it makes you a lot more powerful and you become a lot more relevant to the company, which obviously translates to higher pay, and also have higher value. And pretty much you could actually set a lot bigger tone to the project and direct it to where it needs to be. One thing I would, if you're not really as strong in math, you could look up Essence of Linear Algebra on YouTube to start seeing how this works. And one thing that I would say was really, really helpful is that you would think that if you want to start learning math, you would go to school like university, which is, yes, that is the traditional route and how you would learn math. One of the problem is that math as a profession or as in academia has a certain language, a certain jargon that has to be presented, and it makes it very unapproachable to a lot of people. If you actually go on YouTube, there's a lot of visual math resources that actually help explain a lot of the concepts, and you'll be very surprised that a lot of concepts are actually not that difficult to understand if they're explained properly in more in the layman's terms. There's basically intuitions over the actual formula, because they make it sound a lot more complicated, but when you actually understand the higher level concept, especially with visuals like pictures and all that, you realize, oh, that's all it's doing? That's not as hard. Especially if you ever do coding, a lot of the sorting algorithms, when you actually see it visually, you're like, oh, I understand this. When you're taught it for the first time in code, and you're seeing pages and pages, and you're taught it at a university level, it seems way more complicated than it actually is, right? And this is where, once I mentioned before, I started learning coding, started with web and whatnot, then went to ML and AI. I started shifting, from making models from AI and ML models to actually AI engineering itself. So what is the difference? AI engineering is basically, think of it as software engineering, but you're not necessarily, it's still software engineering, but you're actually using ML models to actually solve the problem, but you're not necessarily building the models. So that would be like an AI research or ML researcher to do that, right? So the main thing about the AI engineer is deployment over actually just building the models like in a research setting. So a company would hire you and say, hey, we need to solve this problem. So it's basically the same thing as software engineering, except that nowadays models are pre-built. You can start using AI models or ML models built into your solution. So that's what an AI engineer would be doing. And the other thing about this is now everything's more project-based progressions. And so basically doing small projects where just learning how to code at first, then learning ML and AI in general, then become an AI engineer. I went from just being a code scripter all the way down to like now a system architect of like, this is what a business problem would be. This is how we start off with. This is our input. This is the final solution or the definition of success. And if you also have the domain knowledge as your advantage, that is going to bring you from scripter to a system architect. And that is what companies looking for is, given the scenario, how could you solve this problem? Build a system that gets us from the beginning, point A, all the way to completion. Let's break down the actual things that you should be focusing on, or basically the high ROI or the high return on investment, right? And this is what I would say. First of all, if you're learning AI and machine learning, get comfortable with Python as a core skill, not because Python is the best language on the planet, though it is a general purpose language and is pretty powerful, especially when you start adding other libraries to make it faster, and it's also easier to learn. But the main reason I would say that now is that 10 years ago, when you're learning ML, machine learning, and you get to build out your own frameworks yourself. Now you have TensorFlow, or mainly people use PyTorch. PyTorch is kind of like the de facto. So when you read a paper or anything's implemented, it's in Python. So get used to it, because that's just pretty much the standard at the moment. It's not necessarily the best, that's just the industry standard when you see code and whatnot. You don't want to have the extra layer of, if you're using another language, read something that's most likely written in Python or code is in Python, and then you have to do that extra layer to convert everything into that. Because now you have to learn two languages. You have to understand Python well enough to convert it to the language that you're using, and they have to both be at a pretty decent level to actually be useful. So just learn Python as a minimum, and as you go forward, then you can learn other things depending on your own scenario. But that learning the de facto is going to make things a lot easier. The other thing is data cleaning. That is, it says here, pays the bills, but that's the main thing. You have to have this skill set, because that is actually what is the actual job in any company, is that they have their own specific data and their own problems, and you have to curate it, get the data, and then actually clean it and make it usable. Raw data by itself is not helpful. You can't just take it and just put it in a machine learning model or an AI model for it to work, mainly because I'll give you the simple example that I use all the time that most people can understand, is that the date of like the actual date of on a calendar is not standardized anywhere in the world. So you could have day, month, year, or month, day, year. Sometimes it's written out, sometimes a whole word, sometimes like even the year could be 4 digits, it could be 2 digits. So if you have a lot of data that's dealing with dates from all over the place, even in the same country or same systems, you could have it represented in different ways. You have to be able to clean it first and basically conform it so they're all consistent before you put it in your machine learning model. If you put it in and you have day, month, year, and the next one is month, day, year, the numbers might not make sense and you might get garbage data at the end. So out of this, for data cleaning, the de facto things you need to learn is basically Pandas and NumPy, right? Pandas is basically, think of it as being able to open Excel sheets directly in Python and process them. And NumPy is pretty much the numerical Python. It's Python by itself. Generic Python is very slow for calculating. Numerical Python is kind of like an industrial strength version that crunch numbers at a very efficient way, right? So you can start dealing with big data and calculate them in an efficient way. It's actually based off of MATLAB. If you ever were in a university setting, and like 20 years ago, MATLAB is like the de facto visualizer and calculations for mathematic calculations. I think it's a software, but it's like $1,000 software. NumPy is free, has very similar syntax to it, and it's very powerful. It's kind of the de facto. In fact, Pandas and a lot of systems are built on top of a NumPy. That's the back end driving it. The other thing you want to look at is pretty much look at papers that be able to implement them from scratch, having that skill set, that's going to separate you exponentially. Because yes, nowadays you can get AI models for almost anything and it works, but when you're in your specific domain and situation, the model that you get might not work exactly as you want. If you're able to actually modify it because you're able to read the papers and understand it and implement it, you're going to be that much more valuable, which usually translates to a much higher paycheck and a greater quality of life, right? And the other thing I would say till this date is making tiny scripts, tiny code. Those are the highest ROI or basically return on investment. Why? A lot of these things are just may seem small, but they really add like quality of life things that make you that more efficient. That it may seem like nothing, but instead of writing down and inserting, reading an Excel sheet and then data entry and writing it by hand into another system, let's say a database, that could take 5 days. And I'm saying that because I've seen this and done this many times in real companies. And they would come and ask me like, hey, we have to import this. Can you write a code? Literally, I look at it within a half an hour. I wrote the code, put it into the system for them, and I press a button, and it did the data entry for them pretty much instantaneously. That saved them an entire week of work. And not only that, it's reusable. That today, till this day, like even like a decade later, it still works, right? And that's the other thing. Things that actually, why tiny scripts is another psychological reason is that it's motivation, because you actually see an end result that has a huge impact that makes things a lot easier for you, right? One thing I would say that is low ROI, that mistakes that people make, that, and again, this falls into people like, hey, I want to learn AI, I want to learn ML. So they just go on YouTube and just go learn one thing after another, and go down a rabbit hole of just tutorials. One of the things, because you'll see like, okay, I mentioned, for example, learn Python, right? You most likely will encounter people saying like, yeah, Python is a general language, you know what? But C++ is a lot more efficient and better than Python. So you're like, oh, I should learn C++. So then you go down tutorials learning all that. The problem with that is like, in this case, I would say learning C++ would be like too early, because now you're dealing with something that Python in most cases could solve it. You're only going to go to this in real world scenarios when you want optimization and you really want efficiency, but you have to know what you're doing in the first place. So I wouldn't recommend anyone starting off with this. In fact, even when people learn C++ as a language, it's so convoluted to a layman person or like a normal person. The concept of pointers and things like that usually they teach you another language that's easier to understand, so you understand the concepts of programming, and then they teach you like C or C++, so you can learn the differentiations of these scenarios and why the optimization actually help. The other thing is people pay for boot camps mainly because of, let's say, a data science boot camp, really because they're like, oh, I know I need to know data science because I wanted to get in AI, and that's a big thing, so I'll learn that. I literally know people who've done this and paid tens of thousands of dollars of it. And the thing is about that is that there's no real goal at the end of it. There's no real projects at the end of it. You're just learning a whole bunch of concepts. And I know this because I taught them afterwards about this. And I'm saying like, yeah, well, the subjects are not necessarily wrong, but there's no focus. Like, what are you getting at the end? You know, like if someone says, I bought a notebook, a textbook on math, and it just tells you a whole bunch of different math theories, and they're not wrong, except that, well, what if you're trying to learn math because you want to be a video game programmer, right? Well, there's certain branches of math and there's certain optimization, there's certain things that you would use it for. Or if you wanted to learn math for, let's say, be a web designer, right? That would be different than what you're looking for. Or if you wanted to learn math because you're actually building physics simulation engines, that would be a different branch. You need to know what the end result would be. So just paying for boot camp without a real end goal in sight can be detrimental for you. And that's why I would say learn these high frameworks, because they're relatively low, they're a lot focused, and a lot of this you could just go on YouTube, find out the basics of it, so you understand to move forward. Remember I mentioned learn just in time, which you need to go. And if you need to learn C++, then you would learn it in your context, but you might be working in an environment that is a work with .NET and they're using C#. I've worked in places where they were exclusively in C#. So everything I would normally do, I had to translate to those frameworks just because that's what they work with, right? Again, we'll learn it just in time. I wouldn't just go out and learn it for the sake of learning it if I'm not going to use it. And one thing I would definitely say, memorizing syntax to me is useless, because especially now you can just look it up. And a lot of these, especially with AI, even if you use like almost any IDE, which is an integrated development environment such as like VS Code, they have some AI assistants with you now where they automatically complete the code. So it's kind of like you don't have to memorize how to spell every word, because you have Word documents that will autocomplete for you, right? Googling is normal. The main thing you want to understand is the high level concept, the system structure, the reasoning behind it, and then all that could be put together. So sitting down doing drills and making flashcards to remember syntax of things in general is not really helpful. The only time that may be merited is if you're doing like a coding interview, and that is kind of like you're studying for the SATs. Under normal circumstances, you wouldn't know this stuff like the back of your hand, because you will just look it up. But for that specific test, you would basically train for that. But rather than that, in day to day, I don't know anybody who memorizes it. Not only that, when you do it often, you just naturally pick it up anyways. With all this being said, the major thing I would actually say is that the biggest skill that I learned that mattered the most, not actually the technical skills, is actually working in a real world scenario, because you have to have a really high frustration tolerance. The same thing when I was in visual effects, film, AAA games and whatnot, is that you could go on YouTube and learn a certain tutorial, and again, it's curated. They give you the perfect examples, everything works, no problem. In the real world, things don't line up properly, and this is supposed to work and it doesn't work. And like, okay, well, what are you supposed to do? You still have to deliver by tomorrow because you have to show it, and it'll be frustrating, and you're looking up for hours trying to get it to work. The main skill is you could have errors all the time, and to be able to deal with that without quitting and persevere and go through it, that's the biggest skills that matters the most, and that's what's going to separate you. Because most people, as soon as there's friction, they stop and they quit, right? And you might not necessarily be the smartest or the best in a certain area, but you don't have to. You have to get to the finish line. And 95% of people quit as soon as it gets tough, right? The other thing about it is that, I mentioned certain things, certain tech stacks today. I mentioned, okay, learn Python today, right? I mentioned 10 years ago that it didn't matter as much because you actually build out your own frameworks. Now, PyTorch is kind of like the de facto, the industry standard. Papers write their code in, everyone's using, right? That's today, right? But tech stack always changes. So maybe next year it might be something else, something better comes along, right? So you have to be able to adapt and stay consistent and know what's going what's going on right now, and stay up to date with it in terms of, and don't necessarily get pigeonholed like this is how it's supposed to be done. Understand this is how it's done now, but keep your ear to the ground to figure out what's happening, because you might have to actually change directions. And you don't have to have a technical background. It's viable, especially nowadays. AI engineering models are already made. You just have to have understand how to put the system together and make it work. I know people who have film background or retail or sales, and you think, oh, they're not technical enough. Actually, this is their superpower, especially like in retails or sales, because usually they're coming to AI because in their own domain, like I mentioned, the domain is a superpower. They have certain problems that they need solving. So they're like, hey, I could use AI to try to bridge the gap and put it together. So there might not be a technical background, but they know what the definition of done is, or what the success looks like, and to bridge that gap to get there. So don't be discouraged if you don't have a computer science degree or was never technical. Your knowledge of what the answer should be in your domain was what separates you, right? The other thing I would say is stop doing tutorials, meaning going down tutorials and just watching one after the other without actually building anything. Of course, when you first start off, you need some baseline tutorials, which I mentioned earlier. I would say learn the basics of Python, learn the basics of Pandas and NumPy. And I would even say Matplotlib, because to visualize, just understand the basics of it, then actually start a real project. And I would say do a tiny script today. What is something that in your own domain that is annoying, that you wish you didn't have to do manually? if you learn how to code it, you could actually solve it. So yeah, that is something I would say, start small, solve a real problem, right? The main thing when you're actually doing anything that's transformative, it's always a long grind before you see a breakthrough. You're not going to see any like instant gratification of this thing, right? You're going to have to do early mornings and late nights, and it's going to seem like you're not going anywhere. That's why it's very, very important where I mentioned stop doing like tutorials, going down a rabbit hole of that, is that, and especially if you're coming from a certain background where you know what the result's supposed to be, right? Have that as your goal, and it might be long to get there, but at least you know that is the end goal over there. And as they say, a thousand mile journey starts with a single step. If you know where your end goal is, and yeah, there's a long way to get there, you just have to solve one thing at a time, as long as you're going towards your goal. If you don't have a certain goal and you're just doing tutorials after tutorials, it's kind of like what I mentioned earlier, where you just get a math book to learn math, but like why you're learning math, it could go anywhere, and what is the purpose of it, right? But one thing I would say, yes, it's hard to do this, and again, frustration, which is the number one thing that matters the most. But if you're able to get through that, just the fact that you get through that, your career becomes future-proof, because now you can face anything. And trust me, when that happens and businesses see you're able to get the job done, they'll give you more and more work, and become more and more valuable. And as they mentioned I worked on the Hunger Games, the film, and I read the books beforehand. One of the things that I thought was very, very appropriate was when the younger sister was telling Katniss that if she wanted something, right? She asked, "Are you important?" She says, "Yes." Well, important people get what they want. Become important, right? Because once you learn these things, yes, it's a long ride. Yes, it's frustrating, but when you have it, your career becomes future-proof.